Hi guys, we are going to take a look at section 6.3. This will be our last section in this particular unit. This is still dealing with rational expressions, but now we're adding and subtracting them. So your directions up here say that we need to find a least common denominator. And to do that, we often will need to factor each denominator first on some of the harder problems, and then we're going to multiply each fraction by different factors from the other denominator. And then you can add together once your denominators are the same. So these two problems on this first page are actually a little more tricky. So I just wanted to be on here to read you the directions first, and then I'm going to flip to the next page and do some easier problems, and then I'll come back and do these. Just so you're aware, this week I do have a review worksheet posted for you with the answer key attached. You just need to walk through and practice those. You do not need to submit that to me. And then this is a short week because Memorial Day weekend is coming up. So your quiz will be open and available for you on Thursday, the 21st. Okay, so here's the first problem that I actually would like to do with you. So for this particular problem, you have two denominators. One of them is a 2 and one of them is 5k plus 5. They have nothing in common at all. So the first thing that you should do is come over here and write your LCD so you know kind of where you're trying to go. So your LCD is simply going to be one denominator times the other. And you'll see on my answer key, I always have that kind of written off to the side so that you know what you're multiplying or where you're trying to get to. So here's our first fraction, 6k over 2. When we look at this and compare it to our LCD, we see the 2 is already there, so the piece we're missing is 5k plus 5. So we're going to multiply top and bottom times 5k plus 5. And then we'll take a look at our second fraction, sorry, that's subtraction there, which is k minus 1 over 5k plus 5. And now when we look at this denominator and compare it to our LCD, we see all we're missing is a 2. So we can multiply by 2 over 2. So now we're kind of ready to distribute and do some algebra. So 6k times 5k is 30k squared. 6k times 5 is 30k. Then we really are distributing this 2 here and here. Don't forget about your minus sign. So you have minus 2k minus 2 all over our LCD of 2 times 5k plus 5. Now we can combine like terms. We have a 30k squared. We have plus 30 minus 2, that's plus 28, minus 2, all over 2 times 5k plus 5. Okay, right here. And then the other thing that you notice is that you can pull a 2 out of all of these. So when you do that, you have 15k squared plus 14k minus 1. All over 2 times 5k plus 5. And here your 2's can disappear because they're the same on the top and the bottom. So you now have 15k squared plus 14k minus 1 all over 5k plus 5. And that would be the end of that particular problem. Some of them are more involved than others. Let's take a look at another one. We'll look at number 5 down here. So for number 5, first thing you want to realize here is this is really 3v over 1. So we want to build our LCD. We always do that kind of off to the side. So we have 6v minus 2 and we have a 1. They really have nothing in common. So we're just going to take the two of them and multiply them together. 6v minus 12 times 1 is just 6v minus 12. So our LCD for this one is just that. This one's going to be more straightforward, because as you can see when we look at this first fraction, it already has the LCD that we're looking for, so we don't need to do any extra work with that. But for this second fraction, it's missing the 6v minus 12, so therefore we're going to multiply by 6v minus 12 over 6v minus 12. Then from here, we're going to walk right across here. So we have 6 here. Then we're going to distribute this negative 3v to both of those pieces. So right here we have a minus 18v squared. And here we have a negative times a negative is a positive 36v. And then on the bottom, we have that 6v minus 12. So we can clean that up a little bit, and we can call that negative 18v squared plus 36v plus 6 all over 6v minus 12. And as we keep going here, we can pull a negative 6 out of everything. I'm going to pull a negative out just so we don't have a negative lead here. So this will be 3v squared minus 6v minus 1. When we multiply that back, let's just check it. Negative 18v squared plus 36v plus 6. And then recognize down here, too, you can pull a 6 out of here as well, right? So then our 6's disappear, and our answer is just a minus 1 out front, 3v squared minus 6v minus 1 all over v minus 2. And there's our answer for that one. Okay. Let's see. Then let's move to the front. And I just want to show you something that's a little tricky. I'm actually going to do B first and then A. So sometimes when you have some denominators that are a little bit more complex, the first thing you need to do is factor each denominator. Now we didn't have to do that on the other side because they were a little more simplified. So this ends up being x plus 2 when we factor it. This one ends up being x plus 2, x minus 2, right? So when we take a look at that and we want to know what our LCD is, I'll come up here and write it. We have an x minus 2 in each. Oh, sorry, x plus 2 in each. So we need to keep that. Then we have another x plus 2 here, so we need to keep that one also. But then over here we have this x minus 2, which we need to hang on to. Okay, so this one actually has 3 pieces to it that we need to pay attention to. Okay, so let's look at this first fraction. And I'm going to write the bottom in its factored form just so we can kind of keep track of things here. So when we do that, we're looking for x plus 2, x plus 2, x minus 2. What we have is just x plus 2, x plus 2. So we've taken care of these two. We need to deal with this one. So we're going to multiply by x minus 2 over x minus 2. Then when we look at this piece here, I'm going to write the bottom in its factored form. It'll make it a little easier for us to see what's going on. So when we compare this denominator to our LCD, we see that we have an x plus 2 already. That's taken care of. We have an x minus 2 also taken care of. But we are missing one of the x plus 2's. So we're going to do that. So these that we're multiplying by is really just us thinking about, hey, here's what our denominator looks like, and this is what we want it to look like. So you're kind of looking at what you're missing. So now up on top, we're going to FOIL these. So we're going to have x squared. Negative 2x plus x is a minus x, and then minus 2 at the tail end. Then we have our denominator on the bottom. We can go ahead and write that. Then here, remember, this is a minus 2 being distributed over here. So we have minus 2x minus 4. I took my line out too far. Sorry. Okay, now we can combine like terms. So we have x squared minus x minus 2x is minus 3x. Minus 2 minus 4 is minus 6. And then on the bottom, we have x plus 2, x plus 2, x minus 2. Now sometimes here you could think about maybe doing some factoring, but nothing's going to work here because the factors of 6 are 1 and 6 and 2 and 3, and neither of those choices are going to give us a 3 in the middle. So this top piece is not factorable the way it's written here, so we would be then done with this problem. Okay, so that one has a little bit more work because you have to really pay attention to this piece of the directions here. When you have a denominator that looks kind of complex to you, you want to first take a look at factoring it before you do anything else. Okay, and then one last problem that's probably the hardest one on here. This is 6x squared. This we're going to factor. We could pull a 4x out of here. So that leaves us with 4x times x minus 3. Now when we're building our LCD here, we want to first take a look at our whole numbers. We have a 6 and a 4. And in order to incorporate both of those, we're going to use a 12 because 6 goes into 12 and so does 4. Then we compare. We have an x and we have an x squared, so we need the larger of the two, which is going to be x squared. And then we absolutely need that x minus 3 that's there as well. So like I said, this is the hardest one that's on my video. I don't believe any of the ones on your homework are that complex. Okay, so now we can take a look and we'll pull our first fraction here. So we have a 6x squared. We need a 12x squared. That means we know we need a 2 here because 6 times 2 is 12. Our x squared is already taken care of. So we are missing an x minus 3 as well. So we'll put that up here. Then for our second fraction, we'll write it in factored form. That'll make things a little easier for us. So we have a 4, we need a 12, we're going to use a 3 to get there. 4 times 3 is 12. We have an x, we need another one. X times x is x squared, then we have an x minus 3. Again, this is kind of complicated. So we're looking here and here to double check and make sure. Okay, when I multiply here, 6 times 2 is 12, x squared times 1 is x squared, 1 times x minus 3 is x minus 3, good shape there. 4x times 3x is 12x squared, and then, oh, we already have our x minus 3, sorry, we just need the 3x, my mistake. Okay, so let's multiply. This is 5 times 2 is 10 times x minus 3, so 10x minus 30 plus 3x squared all over. Now we have our 12x squared, x minus 3 on the bottom, which is what we were looking for. Now we combine like terms, 3x squared plus 10x minus 30 all over 12x squared times x minus 3. And that would be the end of that problem as well. Okay. So your worksheet and your answer key are really more similar to these easier ones that I went over first. There might be one that's kind of similar to one of these, and then your quiz is really more similar to these easier problems on the back here. So I will post these on Canvas so that you can take a look at them. And then try the practice problems that I have posted as well. And then don't forget, on Thursday I'll send you an additional announcement that you can go ahead in and take your quiz. And this will be the last thing that we'll do before Memorial break. Next week we're just going to take a look at some trig functions, some sine, cosine, and tangent. And that will be our last unit of study that we'll be working on just for the last couple of days of school. We'll just have 1 or 2 more things to take a look at. So I'll have office hours Wednesday afternoon, as always, 1 to 1:30. Please feel free to pop in or email me if you need any help with anything. Thanks, guys.